no political, no nationalistic bias.
It's exceptionally important for young African scholars.
It's a leading body of scientific work and sponsoring economics.
Being elected a fellow of the society is a great honor.
When I was a junior faculty, I would go to the summer meetings every year. I got valuable feedback on the work that eventually led to the Nobel Prize.
The year is 1930, and invitations are sent to leading economists around the world to attend a meeting at the Statler Hotel in Cleveland on December 29th at 8 p.m. Its agenda, the creation of an international society for the advancement of economic theory in its relation to statistics and mathematics, which at the time was revolutionary, and to support unification between theory and factual studies in economics and a constructive and rigorous way of thinking, similar to that which has come to dominate in the natural sciences. In other words,
promoting the use of economic theory to study real-world data, thus making economics much more useful in the real world.
They call this new society the Econometric Society. 16 economists attended that first meeting. Irving Fisher, the father of econometrics, was its first president. In 1933, it launched its first journal, Econometrica, now regarded as one of the leading journals in economics, receiving well over 1,000 submissions a year. In 2010, the Society adopted Theoretical Economics, an independent journal since 2006, and launched Quantitative Economics and a growing monograph series.
Econometrica. It's really a journal that's known for publishing important research in mathematical economics, economic theory, empirical work, econometrics, that has a long-lasting impact.
When I was in the World Bank, I saw firsthand how ideas that were published in Econometrica many years ago ended up being influential in actual policy.
Today, the Econometric Society has more than 7,000 members in 85 countries. Here's just some of what it gets up to and why it matters.
What separates the Econometric Society from other learned societies is that it's a truly global organization.
The Society organises up to 10 international meetings and sponsors 6 schools annually, and once every 5 years, a World Congress.
The Australasian meetings always attract an excellent group of international scholars.
In Latin America, the Econometric Society has been crucial for the development of a community of economists working on issues of interest to the region.
And as a woman from China, I really benefit a lot from Econometric Society. But I think not just me personally, I think for all the women Chinese economists.
It's the only society that brings together scientific research in economics and econometrics from across the world.
The Society has always supported the careers of economists.
I published my PhD thesis, my very first paper in Econometrica. That puts one on the map.
Over the last 4 years, we've had a winter school at the Delhi School of Economics, which has been in collaboration with the Econometric Society.
Summer schools provide a great opportunity for young scholars to learn the latest techniques and also to interact with other young scholars in their area and senior researchers in their area.
It's the intersection of economics, statistics, mathematics, and it gives credence, it gives support, it gives recognition to those of us who do mathematical economics, theoretical economics.
The Econometric Society started with 29 fellows in 1933 and has since elected over 1,110 fellows, representing more than 30 countries.
It is a huge honor to be elected by one's peers in the society.
In the society and in the professional general, I have always felt that I'm treated equally with everybody else, regardless of gender, of regional origin.
The Society receives financial support from its members, as well as from sponsors. It completes all of its work on a small budget and relies on the tremendous support of host institutions and hundreds of academic volunteers from around the globe. So how has the Econometric Society fared in its mission? At the latest count, The Nobel Prize in Economics has been awarded 53 times to 89 laureates between 1969 and 2020. Of the Society's 1,121 fellows, 81 have won the Nobel Prize in Economics, representing 91% of all winners. 28 of those Nobel winners have been president of the Econometric Society.
I still find reading the journal and looking at the forthcoming articles as a really important way of seeing what long-lasting innovations are really happening in economics and econometrics.
It establishes such a constant scientific dialogue among people who are geographically very distant. I think that's very impressive.
I just feel part of a family that has been in existence for a long time, and it just brings me a lot of joy, just knowing that the giants were there before me, and I'm trying to step in their footsteps.
To find out more, become a member, or to support the Econometric Society, get in touch at econometricsociety.org.
Okay, so welcome everyone. Thanks for coming. This is the Jean-Jacques Laffont lecture of the Econometric Society, as it would have escaped anyone by now. And I think it is, in fact, very fitting that Joel Sobel gives today's Laffont lecture, because just like Jean-Jacques, Joel is an intellectual giant that has thought about very many different things, although the things are somewhat different from Jean-Jacques' work. So just to give a bit of background, Joel has a PhD in mathematics from UC Berkeley, but there is a connection with Barcelona in the sense that this, first of all, is the time where math and econ were well connected at Berkeley, and it's the time of the brilliant Andreu Mascolell, who I think for a significant part of the effort of getting a PhD for Joel, Andreu helped a lot, together, of course, with the main advisor, who was David Gale, whom I don't know if everyone knows here, but when you talk about Gale Shapley, you're talking about David Gale, so Joel's advisor. And probably if he would have gotten the Nobel Prize together with Roth and Shapley when that Nobel happened, if he had been alive at the time. Now, Joel has, if you're interested in that story, it's kind of a side story, but Joel has written a very nice paper about David in Games and Economic Behavior. It's called Regale, Some Memorable Results. And this, by the way, the reason I bring it up in addition to this is that it shows a knack that Joel has for interesting titles as well as interesting papers. So just to give you some examples, we also show some of the depth and breadth of his work. So one is called For Better or Forever, Formal versus Informal Enforcement. Can we trust social capital? How to count to 1,000? It's not what you know, it's who you play. Or Samurai Accountant, a theory of auditing and plunder. And these are just some examples of a very nice work. Now, he's of course most famous for his work on strategic information transmission, which he wrote together with Vince Crawford, published in Econometrica in 1982, which is in fact very related, or somewhat related, to today's talk, that tries to shed light on what deception means. And of course, it's also related to some large thousands of papers that build on that work. And that's a fundamental advance in game theory. I think part of the motivation for that line of work, which is not always well understood, is to try to figure out how symbols come to have meanings, and these symbols are not just spoken symbols, all kinds of symbols, and why sometimes end up meaning different things that shift over time. And I get reminded of this because my mother likes to sing a Basque song. It's called Choria Chori. I'm going to read you some of the lyrics. It starts, which mean, if I had cut its wings, it would be mine. He wouldn't leave. But like this, he would no longer be a bird, and me, I love the bird. Now, for the Basque people listening in the 60s, this just meant we want, or in addition, it meant we want our freedoms back. And the censors, of course, had a hard time prohibiting it because of the somewhat ambiguous meaning of. So it ended up meaning a secret handshake between the sender and the receiver of the message. And by the way, sender and receiver secret handshakes is a point of another amazing paper that he wrote, which is an evolutionary approach to pre-play communication. That one with Andreas Blume and Youngwon Kim, two of his very good students. And he's also done a lot of other work that I love. So he's made it understand why interdependent preferences might matter in games, but not in competitive markets. That's a paper called Other Regarding Preferences with Martin Duvenberg, Paul Hithus, Georg Kirchsteiger, who's around here somewhere, and Frank Riedel on his work on signaling, equilibrium selection in signaling games. That's also in Econometrica with banks. And he invents a very cool equilibrium selection criterion called divinity. So in case you want to show something interesting to your students. He also has some very nice work on the durable goods monopoly with John Conlisk and Eric Gerstner. I could go on, but you did not come here to listen to me. Now, one warning. Joel is going to start with some kind of apology and self-deprecation. It is, of course, cheap talk. Okay, thank you.
So Antonio knows me very well, and he's a very honest man. So I'm grateful for all of the time that he spent selecting truthful and kind things to say about me. I'm very happy and anxious and honored to be here under the umbrella of Jean-Jacques Laffont, and I hope that we can separate two things. One is honoring the work and contribution of a brilliant scholar who died too young, and the other is listening to me. I hope to connect those things a little bit, and I selected my topic to try to do this. But Jean-Jacques was a scholar and a contributor to intellectual life in ways that are truly extraordinary. We have these signs around our necks, and there are 6 spots where you can put stickers for specializations. For Jean-Jacques, you could easily place public finance and industrial organization and theory and political economy. I think it's not a stretch to add development and environment, and I may be missing some things. So you need at least 6 slots to describe him. I have one here. And that's part. He was a mentor. He and Jean Tirole and others made the Toulouse School of Economics a school of economics, and I've been very fortunate to participate in an academic life, never having to demonstrate that there's a reason for this. And I'm aware that in Toulouse, here in Barcelona, Andreu Mas and Salvador Barbera and Xavier Calsamili and others created a Barcelona School of Economics. And I think that certainly in Europe, but the entire profession should be very, very happy that these brilliant scholars had the energy and the vision to do these kinds of things. And I'm, of course, grateful that somebody somehow did it for me and didn't have to do it myself. And he was not just an economic theorist. He worked on problems that really were relevant, and perhaps even more than that, he could communicate to people who made policy. and truly bridge. I think the word bridge is on this as well. The theoretical work that we honor in the Econometric Society and what our mothers think economics is. So I'm honored to be associated with such an accomplished person, but I am who I am. So I'm going to give a presentation, and when I learn how to use this, I tell you now what my promises are, or what I hope to deliver. And so here are three things. I'm an old person who's realized that many of the words that I use, even in a precise professional way, I don't really understand. And a pedagogic goal is for me to simply define one of those terms. And I want to emphasize that there's a sense in which this task is very, very easy, and there's a sense in which this task is close to impossible. So the easy part is that I'm going to present a formal model, and I'm in charge. So I can define the word, and the word can mean whatever I want it to mean. And we honor this part of theorizing, and I'm with it. I'm completely accept that value of using mathematical language to think precisely. So I'll do that, and that's easy. I make something up. The hard part is that I'm going to use a word that's a common word, and I aspire to have my mathematical meaning relate to the way that people, and possibly people who make economic policy, use the word. And you can decide for yourself. My applied is aspirational, but this topic, more than most of what I work and think about, I think is conceivably relevant and has certainly motivated my thinking of actual cases. So I chose this topic to talk about, to honor Jean-Jacques Laffont, because I aspire to have the kind of communication skills and if you will, substantive chops to carry this theory somewhere. And then technical, alas, this will be the focus of my talk. I got some results, and I'll tell you the context. So we'll look at a very simple model. There are 5 lines here. The basic mathematical analysis is really going to be decision theoretic. So there'll be one person. That person I'll call receiver. My receivers are men. This person will essentially be characterized by a couple of objects. One is a probability distribution over a finite set of states. So that capital theta is a finite set, and the capital delta just indicates probability distributions over. And the other piece of information you need to know about my receiver is his utility function, and it will depend on the state and an action that he's going to choose. Okay, so that's where the formal action is going to be, but I want you to think about a particular interpretation that makes this story strategic. And in the strategic story, there's going to be another player, a sender, and the sender actually observes the state, and she gets to say to the receiver something, a message. Okay, then the receiver hears M, and you reduce this more complicated model into the simple model because the receiver somehow is going to use M to form beliefs over the state. The typical way of doing that is having a prior probability over states and updating using Bayes' rule. My analysis is more general than that, and this is not going to be a key. That is to say, I'm not going to talk a lot about the strategic situation today, but it's essential for interpretations because I want to be able to talk about all manner of behavioral environments where, for one reason or another, the receiver does not decode the message the way that Bayes would. Okay, so what does the standard interpretation do? It makes it a game theoretic problem. It tells you where beliefs come from, but more importantly, I think it allows you to talk about the deceiver. So the sender, by communicating a message, is going to have the potential to mislead or confuse or deceive the receiver. Okay, so that's in the background. It'll appear in the foreground a little bit later on, but I'm going to do a bunch of analysis on the decision problem. So I'm going to define deception. What's deception? And informally, I want deception to mean beliefs are bad. So I'm going to talk about that using beliefs. I've already introduced you to beliefs, and I'm going to talk about that using bad. I haven't introduced you to bad yet. Okay, here's how I'm going to do it. I'm going to imagine that there's this object D of mu, and D of mu takes beliefs and it identifies a bunch of other beliefs that are worse. So I'm going to have a partial order on beliefs. I'll talk about one belief being worse than another. That's a primitive, but I'm going to try to suggest that certain versions of this D are attractive and look at their properties. So bad beliefs are bad relative to another belief. Okay, now I want you to think about that for a little bit. I think that once I tell you that I'm viewing this problem on an interim basis, that is to say, conditional on a true state, you can identify a really good belief. And a really good belief is putting probability 1 on the true state. I think that it's pretty clear that if I have a two-dimensional world where belief is basically the probability of state 1, then you know what the order of beliefs are. If state 1 is the truth, a really good belief is believing state 1 is the truth. A really bad belief is believing state 0 is the truth. The more probability you place on state 1, the stronger, the better your belief is. Okay? I think it's also pretty clear that when you get beyond two states, having a complete order of beliefs is probably asking too much, and probably there are different ways in which beliefs could be good or bad. Okay? So basically, deception is picking one partial order and thinking about it. Okay, so what I'm going to do is start with a partial order in beliefs. I want you to think that there are lots of ways in which beliefs are going to be bad, but I'm going to focus on a way of thinking about when a particular ordering is appropriate. So my title had the words deception and damage in it, and here we are blank minutes into the talk, and I've said damage now for the second time. Let me introduce it to you. Damage is another thing that I'm going to talk about using a partial order on beliefs. Okay? In this case, I'm going to connect the partial order to the utility that the receiver receives. So one belief is going to be damaging relative to another belief if the receiver does worse when thinking using the second belief. What I mean by that exactly, there are two missing elements to the story I've told so far. One is the interim nature, so doing badly is going to be evaluated using the receiver's utility function given a particular state. And the second is, what is the receiver going to do with the beliefs? And my answer is, the receiver is going to choose the action that best responds to those beliefs. So I've sketched out, and I'll write in symbols, a notion of figuring out the implications of having two beliefs. One belief will be better than another if it leads the receiver to have higher utility in the true state. Okay, here's what I'm aiming for conceptually. I want to give you a family of theorems that link these two partial orders together. And a canonical theorem is going to be of the form, if one belief is deceptive relative to another, then it's going to damage all receivers who have a utility in a particular bag. So in one hand, I'm going to have different notions of bad beliefs. On the other hand, I'm going to have different notions of relative preferences, and my game is to link these two things together. So once again, I didn't know that the word bridge was on, but I'm going to build this bridge between partial orders on beliefs and partial orders on beliefs. One of them deception, the other damage. Okay, at last, a definition. So there's symbols here, but I think this isn't hard. If you don't do algebra in your head, there are pictures to follow. So remember, I want you to think of deception in terms of partial orders. I want you to think that there are lots of possible definitions. This is one. So a belief mu prime is more strongly deceptive than another belief in an interim basis, given mu star, if it's a different belief and something. So equation 1 says that the good belief is a convex combination of the bad belief and that I thing. The I thing is the point mass on the true state. Okay, so this is the simple picture. The triangle is the set of all possible beliefs. The upper point is the truth, and mu is some belief. Everything on that segment below it is a worse belief in the sense that it's further away from the truth. Okay, look at that picture, and you can see that I can draw other pictures that have different definitions of worse. You'll see them. Okay, look at that picture, and you'll see that I've got a really partial order. That is to say, there are lots of points in that triangle, but very few of them are comparable. Okay, if you don't like that picture or you need help, this is the same kind of picture. Now the segment describes all the beliefs that are better than mu prime. Okay, again, it's a thin set. Okay, so I told you about damage informally. Let me tell you about damage formally. So deception is a property of beliefs. Damage is going to be a property in some sense of beliefs, but it's going to be derived from thinking about consequences. So I've separated preferences and beliefs about the state, and eventually I'm going to link them back together. So I'm going to assume that the receiver best responds. I wrote down notation for the best response correspondence. So given beliefs mu, let's assume that the receiver takes the action that's best for those beliefs. Remember, there's going to be a true state, theta star. This action might not be the best for that. And so that's where the action comes. Okay, here's the formal definition. Mu upper bar is the utility that the receiver gets if the state is theta, if his beliefs are mu, and he best responds to mu. Okay, you would best respond to theta, but this person doesn't know everything. Okay, definition, mu prime is damaging relative to another belief if that mu upper bar goes down. Okay, down here there's a description of a technicality. I will tell you what the technicality is, and then I will insist that it's not a problem, believe me. So the technicality is the following. That equation at the top doesn't necessarily define a function because BR mu could be multivalued. Now, in terms of mu, BR mu always gives the same expected utility. That is to say, it maximizes the receiver's utility given those beliefs. But in terms of the true state, different maximizers at mu might give different utilities. So it's conceivable that U upper bar is a bag of points. And if mu upper bar is a bag of points, then I have to define that greater than. Okay? So what it says down here is that if you pick basically any reasonable definition to define that, so the strong set order or having a fixed way of breaking ties that is constant across problems, then everything's okay. So I'll mention this technicality again on the next page, but I want you to think it's taken care of. I thought of it for you. You don't have to worry about it. Okay. The last page defined damage with respect to a particular utility. This extends it to a bag of utilities, and I think it's the natural extension. A belief is more damaging for a set script U of utilities if for every element in that, so U upper bar really depends on the choice of preference for the receiver. For every element, the receiver does less well with the putatively worse belief, and for one it does strictly worse. And again, the technicality is that if U upper bar is not a singleton, I have to have a consistent definition of the order. Okay, so here's where I am. I'm now in a situation where I've got two possible ways of generating partial orders. One way of generating partial orders is I think and I think and I think and I say, this is what it means for beliefs to be bad. Okay, so I gave you one example of that, strong deception. The other way of generating a partial order is I make up a set script U, and then I best respond, and I get a partial order that measures consequence. Got it? So over here, I'm thinking bad belief. Over here, I'm thinking bad utility. Okay. Pause. I let economics enter in for a brief moment. It'll be brief, but it'll come back later, again briefly. So the U.S. Federal Trade Commission is charged with regulating, and one of the things they do is identify cases of deceptive advertisement. And they've got a rule book that they use to litigate. And they have a definition of deception that has these 3 bullet points. So deception requires doing something that misleads the consumer. That's not completely helpful because mislead is something that maybe needs definition. Federal Trade Commission's definition emphasizes that it's thinking about some sort of representative consumer. So a consumer that has, I don't know, appropriate preferences, say. And then it emphasizes that deception is something that has a material impact on a consumer. It hurts you. Okay, so this is practice, summarized somewhat informally. And this is me. I've told you about deception, and for me, deception is all about beliefs, but it doesn't have material consequences at it at all. But then I invent this new concept that brings material consequences back into play. So what I'm doing is separating these two issues, perhaps to better understand them, but then to put them back together. Okay, I said something like this in words, but this is the theorem. So the belief mu prime is more some sort of deceptive than another belief in an interim stage, given a state, if and only if it is more damaging than the better belief relative to a particular family of preferences. Okay? This is the first typo I've spotted. That symbol and that symbol are supposed to be the same, so add a star. Okay, so this is an aspiration again, in the sense that I haven't told you what X is, and I haven't told you what f of X is. I've given you one example of X, and that one example is strong deception. Remember, strong deception was really, really partial order. Okay, beliefs using strong deception are ordered conclusively. And the theorem that's associated with the notion of strong deception turns out to be replacing the family of preferences with everything. So if you don't know anything about your consumers and you want to link deception with damage, this result says you have to be very conservative. Okay, so again, generic proposition and then a hint at a formal statement. Okay, now I pause, and I don't put on my economist hat, but I put on my theorist hat. So am I doing something that's completely new? No. And you are familiar with results like this in other contexts. This is one that I think you all know. First-order stochastic dominance is, on one hand, a property ranking probability distributions. One probability distribution is greater than or equal to another. It's another, equivalently, a property about how people with monotonic preferences rank distributions. So your standard characterization of first-order stochastic dominance has, on one hand, a statement about beliefs alone, another hand, a statement about consequences or utility functions, and it connects the two. Importantly, the appropriate notion of comparing distributions depends upon the relevant notion of utility functions. So this line is about increasing functions. Second-order stochastic dominance is about risk averters. Okay, you've seen other examples. Okay, but today you listen to me. Okay, my approach is a little bit different because it's an interim approach and it involves a decision. But if you're honoring this kind of question, you've got to go back maybe to Tardy Lilywood and Polya, but certainly to Blackwell. It's a standard trick. Okay, what am I going to do? I want to show you a few examples of X and f of X. That is to say, I want to show you a few kinds of deception correspondences, and then I'm going to show you the family of preferences that go with them. And what I want to do is convince you that what constitutes deception depends on your evaluation of the context you're in. Okay? So I announced early on that the really simple case is one in which there are two states. In my head, the next simple case is when there are basically two states that matter. So consider this following persuasion problem, not Bayesian persuasion. Let's imagine what the receiver does is make a binary decision. I'm going to buy it or not. I'm going to vote for you or not. So the decision is y equals 0, is y equals 1. And you can characterize the receiver's preferences by identifying an acceptance set, the set of states that the receiver really will want to say yes to. Okay? So this is a pretty simple problem, but it's probably a reasonable problem. So if I'm trying to sell you something, I always want you to buy it, but you only want to buy it if it's good enough. Okay. How do I think about deception in this sense? I think that it's fairly natural to think about deception in the following way. I deceive you if I know that the object is good and I lower your beliefs on it being good. Or I know the object is bad and I raise your beliefs that the object is good. So I think that that's an intuitive notion of deception in this case. And if you want to marry that notion of deception to a family or a bag of preferences, this is the bag. So I don't know what the receiver's preferences are, but I know what the acceptance set is, and the family of receivers I care about are ones that win something positive if the state is in A, and lose something or win something negative if the state's not in A. So these are exactly the preferences that would justify A star being an acceptance set. And you can turn the page, and this is the formalization of what I claimed was the intuitive notion of deception, and this is your first real damage deception result. So again, I'm going to say that a belief mu prime is more deceptive in this context if it raises the probability of A star when A star is false, or lowers the probability of A star when A star is true. And then I have a very simple result. Okay, this one you can do yourself on an index card. Belief mu prime is more binary action deceptive than mu, given the true state, if and only if it's more damaging relative to this class of WL preferences. Okay, so I've identified a problem that I hope has some economic content. I've identified an intuitive notion of deception for that problem. I've identified a bag of preferences that seem relevant to the problem, and I've married the bag of preferences to the partial order of the states. That's my job. Okay, and I'm done, except that I want to do it over and over and over and over and over again. Okay, you want to leave, so I won't do it over and over and over and over again, but maybe I'll do it one or two more times. Okay. I showed you this result before. I gave you the definition of strong deception, and it is the case that a belief is more strongly deceptive than another belief if it's more damaging for everybody. Okay? Qualitatively, if I have a very, very restrictive notion of deception, a partial order, then it's going to be married to a bigger bag of preferences. Okay. This one takes you the front and the back of the index card to prove, and you might need the separating hyperplane theorem. I needed the separating hyperplane theorem, but you can do it. Okay. One more try, and then I'll just wave my hands and say you can do other things. Okay. This is going to be a definition of deception that is less partial than strong deception and applies to sort of more general problems. So I'm going to call belief more proportionally deceptive than another belief given a state if blah, 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 and the operational part of the definition is this thing. If you remember the last definition, it looked pretty similar. There was a mu in it, there was a mu prime in it, there was a convex combination. Okay, if you are good at algebra and memory, one thing that's different is that the mu and the mu prime have been permuted. And the other thing that's different is that I used to have probability 1 on the true state, and now rho is probability 0 on the true state. So the first definition of deception said that a belief was worse if it moved along a line segment further away from the truth. This definition says a belief is worse if it's a mixture of the original belief and something that puts 0 probability on the truth. Okay, words aren't as good as pictures here. That's the picture. Remember before I had a line segment that went down. Now a lot more things are worse than mu. Okay, and again, this is married to another picture. Before, better beliefs were a line segment. Now, better beliefs are full dimensional. Okay, so I introduced this notion of deception. I hope that it's somewhat intuitive. That is to say, the way that you get a worse belief is to add something that's surely wrong to a belief. Okay, and I promised you that all that I do is relate partial orders on beliefs to bags of preferences. So you will anticipate that there's going to be a proposition that says a belief mu prime is more proportionally deceptive than mu given theta star, if and only if it's more damaging than mu given theta star relative to blank. I have to tell you what blank is. This is notation, but here's what I want you to think. Imagine that what I'm going to do as the receiver is pick one object. There's one object for each state. So if I knew that the state was theta star, I'd want to pick the object that was good for theta star. Okay? So you could imagine that, what I'm trying to do is choose between 10 items, and perhaps you as a salesperson are trying to convince me to buy one of them. Okay? I call these preferences state-specific if they have the form that you get something good if you choose the action that's associated with a state, and you get 0 otherwise. Okay? This is almost like saying that you have linear preferences over the simplex. Okay, what I want to convince you of is that this is another environment. It's a plausible environment, and if you trust me, then it's connected with a different set of preferences or a different notion of deception. Okay. So I promised you that I wouldn't overdo it. Maybe I've overdone it, but these are alternatives. Let me say something in words. What will I mean by constrained deception? Constrained deception is going to be between proportional deception and strong deception. Proportional deception says I can mix in probabilities, I can take a belief and add something that's surely wrong. Constrained deception says I'm going to ask for a bad belief to essentially lower the probability of the truth and raise the probability of the false things. Okay, and that's a little bit more restrictive. Leibler measures the distance beliefs using relative entropy. In my setting, that's easy. It translates into I'm deceptive if I do something that lowers the probability that you have on the true state. Okay, if you think about that one, that's the least partial of everything that I said. Okay, so these two things I'll show you a little picture of. This thing I won't tell you a picture of, but you may have been thinking about it already. So everything that I've said before treats states symmetrically. Okay, there is the true state and there is everything else. There are lots of environments in which state 2 is close to state 1, and state 5 is close to state 4, and state 5 is far from state 1. So you might want to ask a question of what's deception in that setting. Okay, that setting seems to be something that corresponds to environments in which you're trying to convince me to buy more. So it's not what I buy, but how much I buy. And those environments suggest, at least to me, as an experienced information economist, monotone environments, so single crossing properties. So you can look at models in which their notion of being further away is a version of putting more weight on states that are further from the truth, with this notion that there's a distance on the states. And you can identify a bag of preferences that basically are sort of standard single crossing preferences and prove another damaged deceptive result. Okay, so again, I want to show possibilities here. The themes are, there's lots of ways to do this, and probably you have to understand the context of your problem in order to know what the right notion of deception or the right bag of preferences is. Okay, so this is the promised picture that explains the two notions of deception that I said little about. So you have seen the green and yellow. That's what I call P deception. The red, green, yellow is the least partial of the orderings. That was KL, or relative entropy deception. And the yellow thing alone is what I called constrained deception. I told the slide to draw a line like this. I just can't see it. But if you can see it, that represents strong deception. So the monotone case doesn't fit on this picture. If you beg me, somewhere in the stack I can show you. But these things show a nesting property. It is certainly the case that among all possible deception correspondences where I could dream of having a deception damage theorem, this one is a maximal one. It's not the maximal one. These things are nested, and there are damage deception theorems that have the set of relevant preferences monotonically changing with the degree in which these orders are partial. Okay, the less partial the order, the smaller the set of preferences. One thing I can, no, I could, but I won't. Okay. I want to bring back the sender for a moment to maybe help you think about the underlying policy context. Okay, so let's imagine that the sender sends messages, and you define the game as I did early on. So the sender sends an M, the receiver hears the M, somehow forms a belief, not necessarily using Bayes' rule, and then best responds to that belief. Okay, it was on the slide, but I didn't mention it. The M could be something that is costly to the sender, but I don't want the M to enter the receiver's preferences directly. And I think that there's a good reason for that. The reason is that if I'm talking about hurting you by confusing you, by inducing bad beliefs, I don't want what I say to directly influence your utility. So if I'm talking about, you know, your baby, then it turns out that your baby actually is ugly. And if I say your baby is ugly, and you interpret it literally, you may have the right beliefs, but you'll be very, very unhappy. The M enters the preferences directly. Okay, I don't. The damage comes from me being ill-mannered, not from me being deceptive. So I rule that out. Okay. And if I want this to be a game of somehow, I need to specify the sender preferences. In the context that I'm thinking about, there's typically a natural way to think about what the sender is thinking about. The sender wants you to buy it, wants you to buy more, wants you to buy its product. Okay. So there really are a list of cases, and I think that I'm going to not talk about them in detail, but they have the flavor of you're a large German auto manufacturer. You have results about how well your electronic vehicle actually performs on emission tests. I guess maybe it was a hybrid. And you announce to the public that it does better. You're a cereal company, and you advertise that your sugary cereal leads to children paying more attention in school, and so on. So there are examples of situations where the Federal Trade Commission has made claims and successfully accused advertisers of deceptive practices, have gotten settlements, and on the surface, it's both obvious that something bad went wrong and not clear that it's the same thing. So in some of these settings, there's a statement that's literally false. In some of the statements, it's misleading. You cherry-pick data. But in all of the cases, there's a sense in which a statement was made. The person making a statement could have made another statement that would have induced better beliefs. There were consequences of the statement being made. The consequences were bad for the audience, and there were sanctions associated with this. Okay, so I want to announce these things. They're general properties of the framework, and they're things to think about and perhaps either embrace or worry about if you're trying to do applications. So one thing is that in my framework, the receiver can always avoid being deceived. Okay, I'm in a strategic environment, and basically I look at you and I say, you can say anything you want, and I'm not going to change my mind. If my belief updating rule is a constant, then you're never going to be able to induce better beliefs or worse beliefs, so you won't be able to send a message that leads to bad beliefs. But if you think about that, a receiver who resists information surely is going to be limiting himself in some contexts, in contexts where the sender has better information and the sender has identical preferences. He's passing up the opportunity of communication. So opening up yourself to deception could in fact be a good thing. So I don't want to look around and either demand receivers never to be deceived, protect yourself, don't believe anything. And I don't want to look around and say, ha, that person was deceived, you go to jail. Okay. If the sender always wants to persuade, so think about the simplest original case, and talk is cheap, so it doesn't enter into the sender's preferences as well, and the prior is favorable, so that if you say nothing, then the receiver will accept, and some messages induce not accepting, so there's something that you could say that can convince the receiver, don't do it, then you get deception and damage in a typical equilibrium. The typical equilibrium is that the sender says something that causes you not to update your prior, you buy the good, but I've created an off-path message that's better for the receiver than the equilibrium message. So in this setting, the sender is deceiving. Okay, this is a simple example, but it's a simple example that says that in my world, deception is something that can happen in equilibrium. It doesn't have to happen, but it can happen. Okay, often we say, well, players are rational, they won't be systematically deceived in equilibrium, and to the extent that that's true, A, it depends on a notion of deception that hasn't quite been formalized, and B, it's relying on average. It's an ex-ante statement. So I'm living in an interim world. I care about the state of nature when Volkswagen lies about emissions, and in that world, perfectly rational players can and will be deceived. Okay, some practical considerations. I've mentioned this. If you look through the cases, in my head, you can classify things, and the persuasion preferences and the are binary decisions. Do I want you to vote for me? The state-specific preferences that are matched to P deception are situations where the decision problem is, what do I buy? Monotone preferences are nicely matched to how much problems. And those problems are different, but they are sort of indexed by what you think the relevant population of preferences is. Okay. More sort of substantive questions. So, okay, so now maybe I get into the room with one of these policymakers. Then they say, all right, I didn't understand any of the theorems, but tell me about deception. And if you tell me it's deceptive, I'll just throw the people in jail. And I say, no, wait. So you could imagine that this all-powerful regulator looks at deception and finds it and then levies a fee that's so great that it never happens. Okay, if you do that, then basically the receiver can force a fully revealing outcome. I believe that you're going to tell me the truth and the whole truth. If you don't, it's deceptive, and my all-powerful regulator will throw you in jail. Okay, you don't want that. The reason you don't want that is that it's perfectly possible in this environment that there's enormous burden on telling the truth. It may be costly to provide all that information. So you've got to be more practical than the theory. This property does depend on an equilibrium selection. That is to say, I said, here, I'll construct such an equilibrium. There are situations in which large penalties for deception help both of the players. So in this land of cheap talk that Vince and I studied, you lose the ability to have mutually beneficial communication because people can't commit to telling the truth. And penalties for deception are a commitment device. But that too depends on an equilibrium selection. Okay. I sort of mentioned this in passing. When you're thinking about how to regulate, one of the things you have to think about is how costly is it for the sender to avoid deception. So this page is inconclusive, and it shows why it's easier to be an economic theorist than a real policymaker. And once again, I go back to the person who we're honoring today. He could do it. I can play one on TV. There are a few other things that you can say. I'm nearly done. You can ask some technical questions. What kind of binary relationships, what kind of deception things really can lead to a damaged deception result? I can write down a characterization. I can talk about what a minimal relationship is. That's easy. It's sort of trivial. You can empty it. Maximal, I indicated that KL picture, so deception is lowering the probability of the true state, is the definition that you essentially can't deceive more. So this is the summary slide. I had sort of two tasks. I had this monumental task of honoring Jean-Jacques, and I hope I have not failed. And then I had these three missions inside of my my presentation. So remember, this was trivial. I get to invent definitions. So you watched me. I was creative. And then it was nearly impossible. I tried to sell you that the definitions were interesting. You decide. I somewhat talked about this, and I do want to leave some messages. So if I had an articulate person who was translating and then whispering into the king's ear, I would want to communicate that context matters. Formally, context is the bag of preferences. Informally, it's the nature of the decision problem. Just to sort of announce that's possible. And then the idea that sometimes your life is very uninteresting if you don't allow yourself to be deceived. And the technical contributions were these theorems that I concentrated on. And there you have it. I have many things that I prepared to say in Catalan. Pro no puc. Moltes gràcies.
Thanks, Joel. Very entertaining. There is time for a few questions if people want.
Thank you very much for the wonderful lecture. I understood that your mechanism allows the receiver to block messages from the sender. But does it also allow to reverse messages? Meaning, I think he's my enemy, I'm still trying to deceive me, I'll use a complement, an inverse.
So it's fully capable of this. So the story says there's some kind of relationship between M and mu, and this was completely in a black box. So the formal theory allows me to model a person who is in upside down land. So in this case, when you say M equals 1, I say M equals 0. My mu places problem. It allows me to model somebody who is literal. It allows me to model somebody who uses Bayes' rule, so looks at your strategy and updates. All of those things are possible. That's both good and it's bad. What you want is somebody wise who can identify what the right rule is. And I will say that I think the critical tension in practice is the following. We as game theorists are sophisticated, and we will look at situations and know, for example, to be skeptical. So if you look at a standard disclosure problem where I have a bag and I can show you how many apples are in it. In this situation, a strategic receiver, knowing that the sender wants to convince the receiver that there are lots of apples in the bag, will be skeptical. If I show you 4 apples, you'll think they're exactly 4. But somebody else might say, think, well, there are at least 4. Do I want to protect somebody who is naive? Do I want to protect somebody who takes statements literally? And the cases are mixed. So there is a case about the energy drink Red Bull that had the slogan, "Red Bull gives you wings." And there was a lawsuit, and you might think on the surface the lawsuit was, well, I drank it and I looked and I didn't have, see, and in fact there was a settlement, but the settlement was any idiot knows that Red Bull was using this metaphorically, but Red Bull didn't even give you metaphoric wings. So in any case, I think there are a lot of situations where the truth is salient and you want to measure deception with that as a benchmark, even though people will be skeptical. And then there are a lot of situations where the literal truth is outrageous and you'll want to give consumers credit for discounting. There are many things that I can say about the recent past president of the United States, but I'm in a mixed audience.
So you had deception relative to a true state. Could you also replace that with a set of states?
So there's a fast answer and a longer answer. They're both the same. The fast answer is that there's a standard trick, and the trick is the state space is what people know. So if it's the case that the most that the sender can know is a set of states, then that's the basic object of study. The slow answer is that if you think about the various things with uncertainty about the true state, some of the notions of deception naturally become a little bit more complicated. So relative entropy, for example, is not just raising or lowering the probability of the true state, because it's not the true state, it's some mass. But to the extent that you trust me when I say something like this, the qualitative message is identical. And you know, you've just listened to a talk on deception, so why? If you've learned anything. There's something I forgot to say. I usually say in talks like this. Many of you know that I'm very embarrassed that I can barely speak one language. But I'm grateful that you all listen to me in English. I am aware that Romance languages use the word that sounds like deception, decepción, decepción. And in Spanish, in French, in Catalan, these words really mean how you're feeling now. That is, the word is disappointment in English. And so I hope that I haven't confused those of you whose mothers did not speak English.